In its simplest form, hashing is the process of converting an arbitrary piece of data into fixed size values, typically an integer value. The data can be a username, IP address, or anything that can be hashed or transformed into an integer value. To understand hashing further, let's take a simple example of load balancer, which is used to distribute network traffic across multiple servers. Here, we have three clients C1, C2, and C3. There are three servers the clients can talk to, but instead of making them talk directly, we'll have a load balancer in between, so that client requests are routed and evenly distributed across servers. When a load balancer redirects or routes a request from a client to the server, it needs to have a server selection strategy, that is, which request should be served by which server. One way of server selection could be randomly selecting the servers. Another approach could be round robin, wherein the load balancer goes through each server in a specific order, maybe starting from top server A, then going to B, and then C, and then going back to A like a loop. However, depending upon the nature of the traffic, these strategies can be problematic. Let's say each of the requests going from the client to server takes a long time to process by the server. That is, they are computationally very expensive requests. One way to deal with the request is caching. That is, each server will have some in-memory cache. So instead of computing the request every time, the server checks if the request has been cached. If it hasn't been, then it actually performs the operation. Otherwise, it skips the operation and immediately returns the cache response, which it already computed for a similar request previously. As you can imagine, if your load balancer is simply selecting the servers randomly or following round robin, there can be a lot of cache misses and unnecessary computation. Let's take an example. Let's say client 1 sends a request. The load balancer uses a round robin approach and routes the request to server A. The server checks the cache and finds it empty and performs a long operation, stores the response in cache and returns the response to client 1. Now if client 1 sends the same request again with round robin approach, the load balancer routes the request to server B. And since server B never saw the request earlier, so it doesn't have the response in its cache. So basically it has to perform the same operation, even though server A already performed the operation and has it in its cache, which is essentially a server A cache miss by the load balancer. That is, cache built by server A was not utilized by the load balancer. We need to have a better server selection strategy in which the same request can be sent to the same server every time, utilizing the cache and avoiding unnecessary recomputations. This is one of the places where hashing can be useful. We can hash each of the client requests coming to the load balancer, and based on the hash value, we can route the request according to the position of the server. So for the sake of simplicity, let's say we have a hashing function given to us, which takes the name of each client and transforms it to an integer value. From the definition of our hash function, we know it takes an arbitrary piece of data and transforms into a fixed integer value. So say when we pass C1 through the hashing function, it is transformed to 11, C2 is transformed to 12, and C3 to 13. A simplest form of hashing strategy is to use the modulo operator, which is in fact the percentage sign on all the hashes, and divided by the number of servers we have. So if we do 11 modulo 3, the result will be 2. That is the remainder when you divide 11 by 3. For 12 it is 0, for 13 it's 1. So all requests from C1 will now go to this server, requests from C2 will go to this server, and requests from C3 will go to this server, maximizing our cache hits and minimizing unnecessary recomputation. Now it's important to have hashing function that evenly distributes requests from each client to server. Like in our case, you don't want requests to be bombarded to a single server, creating a server hotspot. Typically, engineers don't write their own hash function from scratch. They use industry-grade hashing functions such as MD5, SHA1, and bcrypt, and so on. You can be assured that these hashing functions provide even distribution by default. Now, if you're working on a large-scale distributed system, there are high chances that you would end up either adding or removing servers depending upon network traffic or demand. So if we add another server, 4, and do a mod now, server 3 will never be called and we lose even distribution of all the requests. A brute force approach to avoid this is to recompute all the hashes and then apply the mod. But that can be extremely expensive. We need a better solution. Check out my video on consistent hashing which solves this problem.